Okay, we want to look at similarity. Similarity. So now we want to first of all understand what similar shapes are. Similar shapes differ only in size, so that's the only difference between them. Their corresponding angles are equal, so their corresponding angles are actually equal. So similar shapes look the same, right? But they only differ in size. So you have a small triangle here and a bigger triangle there. And as you can see, the corresponding angles are the same. We have 70, 80, and 30. Here we have 70, 80, and 30. So if the angles are equal, right, even though the shape sizes are different, we say those shapes are similar. Now, we want to look at calculations we can make on similar shapes. We start off by understanding the ratio of lengths. The ratio of lengths is consistent between corresponding sides of similar shapes. The ratio of lengths is consistent between corresponding sides of similar shapes. What does that mean? If we have our first shape here with sides that we're going to call x1, x2, x3, and then we have our other shape there, which is y1, y2, y3. If these two shapes are similar, the ratio between these corresponding sides, x1 and y1, is the same as the ratio between x2, y2, which is the same as the ratio between x3 and y3. So the ratio between x1 and y1 is just the same as the ratio between x2 and y2, which is just the same as the ratio between x3 and y3. What does that mean? It means that if y1 is 2 times the size of x1, then y2 is 2 times the size of x2, then y3 is also 2 times the size of what? X3. It means all these are 2 times the size of that. If they are 3 times, all of these will be 3 times the size of those angles. If it's 2.5, 4.5, etc. So the ratios are consistent, and we can actually use this to make calculations, right? So here's an example here. We have the first triangle here, which has the sides 3 centimeters and 5 centimeters. And then we have another triangle which has 6 centimeters and x. And we want to find the length of x. What do we know? The ratios, right, are consistent, right? So the ratio between 3 and 6 is the same as the ratio between 5 and x, right? So 3 over 6, that's the ratio between 3 and 6, is equal to the other ratio, 5 over x, right? So the figures on the smaller triangle is what we're putting on top. The figures on the bigger triangle is what we're putting on the bottom. So now we want to find our x. To find x, we just have to solve this equation we have here now. So first of all, I like to remove the denominator. So I multiply by 6 and x. I multiply by 6x. 6 into 6x. 6 cancels 6. I have x. X times 3 gives me 3x. X into 6x, x cancels x, I have 6. Then I have 6 times 5, that gives me 30. So 3x is equal to 30. Once I get here, I divide both sides by 3, right? That means if I move it here, x is equal to 10 centimeters. So that's it. That's the simple thing. I used my understanding that the ratios of lengths are consistent between corresponding sides of similar shapes. I established that in an equation, and then I solved the equation to find my value of x.